Okay, this PhET is really easy to use. It's just the units you're going to be using. I can't really go over in any kind of depth because it's kind of complicated. So what you do is you have over here, you have your different solutes, the things that you're going to dissolve in the water. Now I want you to keep the volume of water at half a liter. That'll help you save time. So on the lab sheet, what you're doing is figuring out what the concentration of each one of these is to make it saturated. Saturated means you can't mix any more in without it settling on the bottom. Okay, so I'm going to use the potassium permanganate as my example because it dissolves, or it reaches saturation pretty quick. So I'm going to hit that and I'm going to shake it, and it's going to get real dark real soon, and then down here it's going to say when it's saturated. It's saturated. Okay, so I'm going to put this concentration meter over on here, and it says 0.480 mole per L. That means moles per liter. Moles is what we don't have time to go over. Moles is a measurement of stuff. Like, you can think about it as actual number of particles. So in here, in this solution, I've got 0.48 amount of stuff per liter. Okay, so let me give you another example, and then you can just keep the meter here through the whole lab because you're going to need it for the whole thing. I'm going to reset it. Okay, and I'm going to try a different substance to show you how this works. So I'm going to take my little meter and put it over here, and I'm going to shake it, and I'm going to shake it until it reaches saturation again. And you got to be careful toward the end. Almost there. Oh, it's saturated. And you can see those little particles down here at the bottom. Just like I explained during the other video where you have the sugar down at the bottom of the glass of iced tea, it's saturated. You can't get any more to actually dissolve in there. This concentration is 5.210 amount of stuff per liter. So this one, you can actually put more of this stuff in the water before it reaches saturation than you could with the potassium permanganate. So you would say that the nickel chloride is more soluble than the potassium permanganate because you can dissolve more of it into the same amount of water, just like I showed you with the salt and the aspirin. Now to do the lab, you're going to keep this for most of it at half a liter. Okay, so I'm going to reset it. One thing you are going to have to do though is you're going to have to either add water, okay, or you can take away water. You can also get it to evaporate. Now you don't want to do that, that's way too fast. Okay, you're going to have to do this for one of the analysis questions. You're going to have to do this real slow, because really what you're doing is, if I put this potassium permanganate in there and I give it a little shake, and it's not saturated yet, okay, but if I evaporate it slowly, oh, now it's saturated. And one of the questions is, why does it become saturated when you don't put any more of this stuff in? And then another question will be this here, and then as I add water, that number is going to go down. Why is that? Okay, so that's how you are going to do the PhET. Okay, so you pick like the drink mix, and you put the drink mix. Oop, I'm going to reset it. Put my little meter in there. I'm going to add drink mix until this says saturated, and write down that concentration in the data table that's on the PhET worksheet. Okay, so if you have any questions about this, let me know. But it should be pretty straightforward. You're just seeing how much of the solid solute goes into the solvent, which is water, before it becomes completely saturated and you can't dissolve any more in. Okay, so if you have any questions, let me know, and I'll make sure to get back to you. Okay, take care.